Hello, my name is James Glennan and I work in systems engineering at White Hat Security here in Belfast. And this is my talk, Changing Airplanes Mid-Air the Cloud Native Way. So a couple of caveats before we get into it. The first one is that this may not be the best way to do this. We've already started thinking about how we would redo some of this or how we would do this stuff again. But the bigger focus for us was backwards compatibility, and that was the primary component that we had to think about implementing a lot of this stuff. The second one is this great quote, I think often attributed to Newton, is "I stand on the shoulders of giants." A lot of this hard work, a lot of the setup for all of this to make this possible came before me. I've only been in this role for 18 months. I've only been here in Belfast for about 2 years, for about 18 months actually. So large portions of this have been set up before I arrived at the company. And the third one is human knowledge. So I'm hoping that you have a basic understanding of Kubernetes resources, and some of the things that I talk about today aren't foreign to you. So, and the last one is art is never finished, only abandoned. And I say that because we're not finished. We're still maintaining some of these older systems that we're trying to decommission. And like, as I've said here, the old plane is still flying, but we're starting to make moves to really turn off the last fragments. But we're also reimagining components of this system to take better advantage of the cloud. And again, I'll talk about a little bit about that at the end, about where we go from here. So quick background about the company. We've been around for about 20 years. We offer a range of services, but the product's primarily application security testing, both dynamic and static. Today, I'm focusing more on the components that serve our customers directly. We do have other components that are related to our internal tooling. There's a whole host of applications there that I'll largely be ignoring. The other thing is we're in a bit of a trend. Well, we were a bit of transition required by last year. We're thinking at the moment about how we can be more robust and how we can allow for some of this future demand that that we're planning to see. And that's become even more prevalent now that we're talking about COVID-19 and the big push for companies moving to online services and into the cloud and that sort of thing. So yeah, as I said, we do DAST, we do SAST. Our stack is primarily old Perl APIs and our new Go React stack. So some of these old APIs are still kicking about. I did say we've been around 20 years, so but yeah, our more modern stuff is all written in Go and our front end is in React. We have also containerized everything by this point. So pretty much if there was something we had to deploy, it was in a container. And before all of this big transition, we were deploying to various VMs that lived in our on-prem data center, and we had a host of cloud-hosted stuff, primarily for the production EU. So, and then yeah, the last thing is that pretty much all of our backend communication is all RESTful. So, and that is a little bit more important as I talked about our API gateways later. So our big problems with this deployment was that there's no centralized orchestration. How do we know what's running, where it's running, and how can we check on it without logging into each environment and physically looking at it? What is our process for adding new services? For example, a few months back, we added mobile scanning capabilities. What is our process for handling that from the developer perspective? What about environment consistency? How do I know EU is the same as US? What happens if I open a third area or a third data center, and how do I make that environment consistent as well? And can we maximize our uptime for our updating our containers? What about when we're updating our API gateways? All of these sorts of problems. And the last real big one is this process familiar to our developers? Is this the best possible way we could be doing this, and the easiest possible way we could be doing this? So the focus areas, I've got 3 today. So the first one, the big one, was we wanted to move our workloads to container orchestration. That was the big sort of must do from our situation. We've made the effort to sort of split our services into microservices, and we had all these containerized workloads. So the obvious next step is, how do we orchestrate those workloads? The second one is, and it's sort of as a product of the first one, can we simplify our service routing? Can we untangle all the apps and configurations that we've built up over the years? And a big component of both those first 2 focus areas is can we reduce cognitive load, and can we maintain a separation of concerns? And so what is cognitive load? Cognitive load relates to individuals only having so much brain capacity to perform their job. That sounds quite harsh, but my quick look up on Wikipedia tells me that it's about the amount of working memory resources, but more broadly, we can refer to it as the amount of stuff somebody needs to know in order to do their job, or to be able to effectively manage their responsibilities. But yeah, plainly speaking, it's how much do I need to know to do my job? So ideally, if we reduce an engineer's cognitive load, we can make them more productive, especially by abstracting away unimportant stuff and automating a lot of the toil. That's a big one. So our solution was migrate to Kubernetes. Of course, we just throw it in Kube, and that's that. We walk away and call it done. So here's where the real problems come to fruition. But first, the things that it does solve for us. So our first problem was about knowing what's running and where it's running and how it's running. Well, out of the box, Kubernetes provides a lot of that for us through health checks and monitoring, and through the controller nature by spinning containers up when they go down and things like that. So we kind of put a big check mark there. The second problem is about consistent environments. Well, deploying to an application requires writing a specification. We call them Kubernetes manifests, and they essentially deploy to any cluster from dev environments, testing environments, all the way to production. I'm skipping a lot over there. Of course, there are different concerns in those different environments, and there are various solutions out there that help solve that. But broadly speaking, it solves that problem for us a little bit. The maximizing uptime, well, as I said, it's as simple as utilizing the controller mechanisms. So it spins up new versions of a service and checks that they're running before terminating the old ones. And also that allows us to roll back, and if anything were to go wrong, using the manifest versioning. So in the event of failure, we're quite easily be able to roll back. But yeah, like I said, with a bit of hand waving, we can solve all of these problems. But so these last 2 points here is, well, the first one is, what about the process for adding new services? How do I do that? Well, like I said, just write a specification. Is that process easy? Well, maybe not. Is that process familiar? Again, maybe not. Kubernetes has been around only about 6 years, and at the time, our organization didn't have that much familiarity with it, or any familiarity with it, I should say. But the other point that I sort of want to bring up is that we have multiple API gateways and proxies serving traffic, and that related to how easy was configuration able to manage. That's kind of the second point I'll be talking about later. So difficulty of the new process is proportional to the familiarity of the old process. And this was probably the real issue, is in any big sort of transition, a lot of questions are going to be asked. How do I do X? Why can't I do it the way I used to do it? Things like that. And so, what do we do? Well, I guess the question we kind of have to ask ourselves is, especially when we're talking about trying to reduce cognitive load and trying to abstract away components, what do developers care about? And so this is, I'm going to talk about separation concerns. What developers shouldn't have to worry about: is my service highly available? Do I have valid certificates? Do I have unlimited, memory to use? Then it shouldn't have to be on their concern to worry about those sorts of things. The things that they do worry about, they need a workload schedule. They need a container running somewhere. They might need it to connect to databases, and they need to respond to specific API requests. Perhaps it also needs to talk to some external services like Salesforce, or I don't know, maybe there's an object storage sitting somewhere that it needs to be able to access. An individual can't, excuse me, the individual can't possibly expect it to understand or know everything on our flight manifest. They can't know how the whole plane is built or how the whole plane is put together. And that being said too, is that one part of the organization shouldn't be building and deploying applications necessarily that different to the other. And again, I'm sort of hand waving over that a little bit, is obviously you might have very specific concerns and very specific processes in that regard. But for us, we need to define the consistent configuration and automate a lot of that process away. Or at the very least, just abstract it away. So just a quick primer on Kubernetes operators. Again, if you're not familiar with Kubernetes, I apologize in advance. But yeah, they extend the Kubernetes API using something called a custom resource definition, and it allows us to deploy custom resources. And these can be anything. As long as we write some specification, we can let our API server accept new resources based on that specification. And then we use an application called a controller to operate on that resource. So it will sit there and monitor for those resources and perform some action on when those resources exist. The time-tested example I've heard before is that if I create a resource called pizza and I apply it to the cluster, an operator comes along, sees that pizza, rings up your favorite restaurant and orders your pizza for you. And these controllers are able to interact with, they're also able to interact with the Kubernetes API. So in our example, that we were able to deploy new Kubernetes native resources, and that seems to be the standard way that they work. The pizza example is a little extreme. Yeah, so with that in mind, we built our own operator to handle something called a microservice. So this is our own custom resource that we developed. We were able to identify the very specific pieces that developers cared about that would allow them to easily deploy their application in our production environment, or in testing depth for that matter. So this allows them to choose their, it allows them to specify certain configuration. Obviously, the ones that come to mind are your images and the name of your application and things like that, but also extending towards things like the API paths, the API endpoints that it's serving traffic, serving on, and yeah, and a whole host of things in sort of that regard. These microservice objects default to a deployment, but they have options to allow you to specify a cron job instead, or a stateful set. And there's been a bit of talk about extending some of that functionality, but that's where we're at now. Those two recent additions. So how it works is it watches the Kubernetes API for microservice resources. The first thing it does is it generates a Prometheus service monitor. If you're not familiar with service monitors and the Prometheus operator, I suggest go check that out because it's a very handy tool. It generates the service resources with annotations about service routing, and it generates the deployment configuration, including all of the volumes, config map secrets, all the things that they could possibly need or want to deploy. The last thing it does is it will add, we have certificates managed by a certificate manager in our clusters, and it will add a certificate to those microservices for HTTPS traffic. internal to the cluster. Yeah, so taking all those resources, it applies them to the cluster, and lo and behold, we should have some pods and spin up which serve traffic. So why are we doing this? Well, we want to reduce this cognitive load on developers. You know, if I want to connect to our NFS server, okay, just specify the required volume. If I want to query Salesforce, okay, load the credentials in and off you go. You know, if I need a very specific environment variable for my one application that's never going to need or use this again, sure, you have the ability to specify those very snowflakey things. So we allow developers to get as specific as they want, and they can learn as much as possible about the very specific way their workload is being applied, or or they can choose to specify none of that, and we can reduce that cognitive load. They don't have to necessarily understand how all the nuts and bolts fit together, but we can sort of still have them concentrate on just developing and getting their application to work, and then testing that application. They don't need to worry about all the gritty details about deploying that application. So, of course, if we get too specific, as I said, you know, there's sort of snowflake components. If we get too specific, at a certain point, the abstraction becomes moot, right? You know, the operator currently doesn't support things like init containers, sidecars, custom readiness, mounting multiple certificates, none of that. So in that case, that obviously a developer has to default back to the standard native resources. So in that front, like I said, is if developers want to get that specific and they need that level of specificity, then sure, they can go and apply those deployment manifests themselves and develop those deployment manifests themselves. But in this regard, for the large majority of cases, and I'd say at least 99% of cases, we don't have to worry about that. Don't have to worry about pod template specs or labels or anything like that. All of that is just abstracted away by the operator. So my next sort of piece we're going to talk about is service routing. So our existing setup was quite complicated, and it was not robust. Changes to it frequently brought it down. And that was largely due to just inconsistencies between different proxies. So this is how it used to look. There's a series of proxies. We have a load balancer, load balancer on the left-hand side that leads to our first proxy, which was HA proxy, and it routes off to various services and microservices. And but by and large, most of the traffic routes through to the API, the Nginx API gateway we have on the right there, and that's the thing that does a lot of the heavy work routing to all the individual microservices. And there is one little piece there where it actually does route off to a sort of third API gateway or a third proxy, and that routes to its own set of services as well. So as I said, it was quite a complicated setup, and we frequently needed to simplify it. And we wanted to simplify the number of hops quite obviously between a user and a eventual microservice. But we also really wanted, like I said, reduce that cognitive load and simplify how the service was configured, and make it so that developers didn't have to do 5 PRs or 4 PRs just to get their service deployed. It was just a case of reference it once and have sort of one central source of truth about what is serving that traffic. So we moved to Envoy, and again, we just have our front-end external load balancer, and these route to our individual Envoy instances or Envoy replica sets inside the Kubernetes cluster, and then these do the actual routing to the microservices themselves. So for dynamic configuration, we wanted a way to generate Envoy's configuration. Like I said, we want to abstract away the proxy, and we excuse me, we also wanted to reduce the number of PRs and different technologies that a developer needs to know. And what I mean by this is, obviously the PR thing's obvious. What I mean by is that Nginx configuration is a little bit different to HA proxy, which was a little bit different to our custom service that was proxying traffic itself. And so it was just a bit of a mess, and we wanted one uniform way of defining these routes and a way that was quite obvious to the user. We also wanted a way to specify that configuration at deployment. So what I'm talking here is a little bit of service discovery. How do I inform Envoy about my app? How do, when I deploy a brand new app, how does it know it exists? And without me going to edit that configuration manually, I should be able to just deploy the app and Envoy picks it up automatically. So we developed a service called Traffic Director. It's not affiliated with the Google service, the same name. I think we came up with ours first, or at least that's what I'm told. And it's just another Kubernetes controller. And this time it's monitoring Kubernetes service resources and looking for annotations that add in extra information about the service. So specifically your paths, the methods on those paths. We also have the ability to specify a few custom headers and functions that only our system is capable of, requires. And simply put, it's an Envoy control plane. Envoy monitors this service for its configuration. And when a microservice is applied to the cluster, Traffic Director picks up that new service object, looks at those annotations, and is able to then regenerate the configuration, and Envoy picks that up. And lo and behold, we have a brand new routing configuration. So you're probably thinking, if you're familiar with this, big deal, right? Ambassador and Glue can do this too. And these aren't new concepts to do this, to have an Envoy control plane. It's quite a normal way to go about it. But the reason I bring it up is because our legacy migration meant that, like I said at the start, we required very specific functionality, very specific backwards compatibility. And we designed it with that in mind. But the second thing also was that those projects weren't necessarily at the maturity we needed them when we began the process. And probably if we had to restart this again, we probably would go back and take a look at them again and see what we can pull apart out of there. But if we did that, it would require us to rework how our authorization works in all our applications. So this is sort of the final part. Did we crash? Yeah, we did. Yeah, we crashed hard. So this is the part where we learn stuff. Sometimes stuff breaks. We can either cry about it and blame each other, or we can work together to fix it. So, when something does go wrong and nobody knows why it's broken, we work the problem and we have each other's back. Of course, if it breaks too often, we do get the question of why are we messing about in here anyway? And going back to what I said about communication, it's important to, what I'm about to say about communication, it's important that we explain mistakes and problems that, the problems that we're solving both long-term and short-term. So this is the part where I'm saying about communication. And I think it goes without saying that any massive undertaking requires communication, quite obviously. But even when you think you've communicated with everyone, you've told everyone everything, there's always someone that wasn't listening. So just bear in mind that, make sure you really drill that stuff home. And for us, that was just a case of we told everyone who would listen to us that something's changing in 3 weeks, 2 weeks, 1 week, it already changed. Yeah. So that was hard, but for us, we then made an active effort to consolidate and triage issues that required our input. Broadly speaking, that means that we created a central place that everyone that wasn't sure what was happening could come talk to us, or even just via email or Slack channel. We were able to just say, if you're having problems, say for example your developer environment doesn't work anymore, you can come to us, you can talk to us, you put your quick question here, everyone can see it and everyone can learn from the same thing. So I mean, the other problem then though is that this also sort of creates dependencies on us, and it then means that we're then required to solve every issue that comes up, which is a little bit ironic when you think about it, because the idea was to try and reduce those dependencies on us by letting the developers own their own deployment, right? But yeah. And then, and the third part is never to assume anything. So we broke our old services when we migrated this, and we actually broke them a couple times now that I'm thinking about it. These parts weren't externally facing. Thankfully, this was just for our internal tooling, but it did create problems. And it did mean that certain things were down for quite a long time. But that just came down to our assumptions. We assumed that the authorization handling was the same in our client-facing stack versus our internal stack, and yeah, you just can't assume these things. So yeah, that was fun. So yeah, I guess the outcome is, like I said at the start, we're here now. We're not done. Yeah, there are components that I wouldn't technically call microservices in our stack, but we are starting to extract and untangle those pieces to make it more modern. But the big thing that I guess we learned from this process is decoupling. And I know we talked about centralized configuration and things like that, but there are certain legacy systems that are so tightly coupled that we're now rethinking how we implement those systems. And our next set of projects are geared with dealing with those issues. So we'll see how we go. And the other thing, yeah, is databases. Our databases still live in their own sort of land, and we're still figuring out how we're going to implement those pieces. At least if we can do it in some sort of container orchestration, that would be really cool. So yeah, the future. Just a quick dots. I think I'm running out of time. So yeah, we're moving to cloud, taking advantage of Azure. That's our sort of big push. We're overhauling our API layers. We're moving to micro front ends. At the moment, we have a big monolithic front end. And I know specifically for us, we're going to implement Service Mesh Next for gRPC load balancing, and that's related to the work we're doing with GraphQL. So watch this space. Obligatory plug for the company. If you're interested in working with us, please come check out our LinkedIn, come check out our website, and come say good day. There are a couple of positions up, so be good. And yeah, thanks for listening. Thanks for coming to my TED Talk, and cheers.